This is Unit 5, Lesson 3, and today we're going to explore two more methods that we can use to solve quadratic equations. We're going to take a look at a method that is most likely new for you called completing the square, and we're also going to review our quadratic formula. So completing the square, backtrack. Remember we learned about factoring, and we said when to use that? Well, when it's easily factorable. And then we also take a look at the square root method, and we said to use that when you have no middle term, the b term. All right, so completing the square, when is the best time to use that? When you have a quadratic that you can't factor, but when a is equal to 1, once you learn this pattern, it can be really quick and simple. It's just a matter of remembering the steps. And then our other is a quadratic formula. So you can use the quadratic formula for any quadratic, right? While our other examples or other methods do have some restrictions to them, quadratic formula could be used anytime. It's just that sometimes there's a simpler way to do it than plugging the numbers into the formula. Like if it's a quick, easy quadratic to factor, I would factor, or completing the square can be easy too. So you definitely want to use a quadratic formula when you have a quadratic that you can't factor and a is greater than 1, versus completing square, something you may want to use when you have a quadratic you can't factor but a is equal to 1. And we're going to take a look at why, because we'll take a look at the example when a is bigger than 1, and we'll use both methods, and you'll see why the quad formula might be better for that. All right, so completing the square is a method we use to make a trinomial factorable so that we can actually take the square root of both sides. So it's kind of combining some different things here. So the first thing we want to do, taking a look at our directions, is move our constant to one side, to the opposite side of our equal sign, so that you have both x terms on the left. Then we're going to take our b value, divide it by 2, and square it, okay, and add that number to both sides. Then our left side should give us a perfect square trinomial, so we factor it and square root each side. All right, a lot of steps. Once you see it, it's not though, once you get the hang of it. Okay, so let's take a look at this first example, and I'll explain what all of those words mean. So the first thing you want to do is to isolate the x values, meaning move the constant to the side by itself. So really, we're kind of isolating the constant by itself over there. And remember, when I move something to the other side of the equal sign, I'm undoing it, so really it's becoming the opposite sign. All right, now what I want to do is this step right here tells us to find half of b and then square that number. And that number is being added to both sides. Because what I'm doing is when I'm finding half of b and squaring it, I'm making a perfect square trinomial. So in this first example, I'm taking the 6, dividing it by 2, and then squaring that value. So 6 divided by 2 is 3. 3 squared is 9. So I'm adding 9 to both sides, because do keep in mind that equations should always be in balance. So whatever I do to one side, I need to do to the other. Now over here, I created a perfect square trinomial, right? Because when I factor this, I'm going to end up with two factors that are the same. That's what we mean by perfect square trinomial. Two numbers that multiply to 9 and add up to 6 are 3 and 3. It's really just my b over 2. It's this number that I got right here. That is what it breaks down into. So I have x plus 3 squared. Okay, I can write it twice, or I can write it with a squared sign, because that's going to help me as I go along. And then when I combine my like terms over here, I have 2, right? Because the negative 7 plus 9 is 2. So now I can go ahead and take the square root of both sides, because I have a perfect square on the left and not a perfect square on the right, but we know how to work with radicals. So if I go ahead and square root it, so over here I just have x plus 3. Okay, so we made it so we could square root both sides. And over here I have the positive or negative square root of 2. I can't break down 2, and there are no i's, so I'm good there. Last step, solve for x. So I'm going to go ahead and move the 3 away by subtracting it. So I get negative 3 plus or minus the square root of 2. Typically, when we move a number over, we're keeping it in front of the plus or minus sign. Whether it's an I afterwards or radical, same thing. So my answer is negative 3 plus the square root of 2 and negative 3 minus the square root of 2. All right, and if I were to use the quadratic formula, I should get the same thing. All right, so our next example, we have an a value greater than 1. And I'm going to show you why in a situation like this, it might be better to use your quadratic formula. But yeah. Okay, so we want to go ahead and move our 2 over. So I have 5x squared minus 4x equals 2. Now, in order to do completing the square, your a has to be 1. We can't have an a greater than 1. So what I can do is divide everything by 5 because that's going to reduce that first one and give me a 1x squared. So that's fine here, but if you notice, now I'm going to get fractions, which that's fine. Fractions are our friends. However, it can make things a little bit tricky as we go along if you're not as comfortable with our fractions. All right, so now I need to find half of 4/5. So remember, if I'm dividing 4/5 by 2, I'm really multiplying by 1/2. Dividing by 2 is the same as multiplying by 1/2. So I end up with 4/10, or 2/5 if I reduce. Because if you have 4/5 and you cut that in half, you have 2/5. And that's the number I'm squaring. So I'm doing 2/5 squared. So 2/5 squared gives me 4/25. And oftentimes it's seen when people try completing the square when you have a fraction like this. This is a step we tend to mess up. We forget to cut 4/5 in half. So please just be careful there. All right, so now when I take the left term or the left side and I put it into a perfect square trinomial, it's going to be half of the b that ends up going in there, or this 2/5 right here. So I have x minus 2/5 squared. And over here I get 14/25. How did I do that? Well, I just changed this to 10/25. So they had the common denominator, right? 5 times 5 gave me 25. 2 times 5 gave me 10. So now I can go ahead and square root each side. Square root, square root. So I have x minus 2/5 equals plus or minus square root of 14/5. How did I get that? Well, square root of 14 can't be simplified, but the square root of 25 is 5. So that's kind of nice. I can just go ahead and root that one. All right, final step, add 2/5 to both sides. So I get x equals 2 plus or minus the square root of 14/5. Okay, so I can still use completing the square when a is greater than 1. It just can get a little bit tricky when I'm working with my fractions and cutting in half and squaring it, so please just be careful. And we will take a look at the same example in just a moment with a quadratic formula, so you can see why maybe that's the better choice in this situation. All right, so quadratic formula. When to use it? Once again, can use it whenever, but best to use it when you have a non-factorable quadratic when a is greater than 1. And this formula we've seen before, negative b plus or minus b squared minus 4ac all over 2a. All right, so how do we do it? Just like with factoring, everything does need to be on one side of your equal sign. Then you can identify your a, b, and c, plug them in, and simplify. So really it's just plugging into a formula. So we've got x equals -5 because it's the opposite of b. Square root of b squared, so 5 squared, minus 4 times 3 times 1, all over 2 times 3. All right, simplify under the radical first. So I've got 25 minus 4 times 3 times 1. So I have 25 minus 12, which is 13, all over 6. Okay, and I can do the 5 squared minus 4 times 3 times 1 in one step. And then see if you can reduce anything. Can I reduce that radical? No. Do I have a negative underneath I need to worry about? No. All right. So let's go to this one now. And we should get the same answer, but let's take a look at our steps. So we'll go ahead and say x equals -b, or the opposite of b. So the opposite of -4 is a positive, plus or minus the square root of b squared, minus 4 times a, which is 5, times c, which is -2, all over 2 times 5, or 10. All right, so I get 16 plus, that ends up being, so all that when said and done is 56, right? So you got 16 plus 40, all over 10. All right, now we've got to see if we can reduce what's under the radical, which I can. 56, I can pull out a perfect square factor of 4, and I'm left with 14. So when I take the square root of 4, I get 2. And then I can reduce, because I have all three of the numbers are divisible by 2, so I can reduce, which is how I end up with the 2 plus or minus the square root of 14 over 5. So I did get the same answer as when I did it with completing the square, which I should have, but a little bit easier in this case. So when that a is greater than 1, you're more than welcome to do completing the square. Might be easier to do the quadratic formula though. All right, so on the back, we got some practice. So let's do one of each together, and then you can go ahead and pause the video and try the others on your own. But let's do numbers 1 and 6 together. The entire left column, I'm going to do completing the square with. Why? Because they're all have an x squared or r squared, whatever your letter is, value of 1. And the entire right column has a coefficient there greater than 1, so I'm going to use my quadratic formula. All right, so taking a look at number 1, I'm going to move this 53 over first, giving me negative 55. And now I need to take my b term, cut that in half and square it. So I'm doing 12 divided by 2 squared, or 6 squared, which is 36. And I need to add that 36 to the other side. Don't forget to do that to keep your equation in balance. All right, so my perfect square trinomial, two numbers that multiply to 36 and add up to 12 are 6 and 6. And then over here I have what? Negative 19. Go ahead and square root each side, giving me x plus 6 equals plus or minus I radical 19. Okay, I can take an I out because of the negative, but I can't reduce that 19 at all. Then I can move the 6 over. Negative 6 plus or minus I square roots of 19. So once you get the hang of completing the squares, guys, it's pretty simple. It's just, once again, remembering the steps, knowing the order and the pattern that you need to go in. All right, let's take a look at number 6 because we're going to use a quadratic formula on that one. Now, before I go ahead and do it, I need to make sure that I move everything to one side. So I'll move it all to my left. Oops, didn't mean to write an equal sign. Okay, that will make that a negative x and a negative 3 when I move those over. So now when I plug it in, I have x is equal to the opposite of b, so a positive 1, plus or minus the square root of negative 1 squared, minus 4 times 7 times negative 3, all over 2 times 7. All right, so I'm just going to kind of move it up here to give myself some more room. I get x equals 1 plus or minus the square root of 1 plus 85? 7 times negative 3 is negative 21 times negative 24. Negative 4 is a positive 84. Yep, 85 all over 14. All right, can we reduce? 85, let's see, can be broken down into 5 and 17. So no, it is not simplified. I can't simplify it. So that's my answer. All right, remember, every quadratic should have two answers. So in this case, it's 1 plus the square root of 85 over 14 and 1 minus the square root of 85 over 14. All right, go ahead, pause the video, give these a try on your own, and then you can press play again and take a look at the work and the answers. All right, and we're back. Okay, so let me scroll up so you can take a look. I'm not going to talk through every single step, so if at any point you need to pause to look at the work a little bit more, please do so, okay? Just because I move on does not mean you need to. But number 2 is pretty straightforward. You can see my answer is a negative 4 plus or minus the square root of 5. All right, so take a look at the work for 2 and 7. Once again, if you see something you're not sure how I got it, please do come in and ask me. One thing I do want to highlight on number 3 is, first of all, I got whole numbers. I didn't get radicals or i's or anything. So that what that means is that the original problem was factorable. So I could have used that method, but completing the square did work fine. When I got down here and I subtracted 9 on both sides, I cannot leave it as this. You cannot leave it as negative 9 plus or minus 1. You actually have to go through and do the math because you always want to simplify as much as possible. So I did negative 9 plus 1, and that's how I got the negative 8. And negative 9 minus 1, giving me negative 10. All right, next door, number 8, I ended up with a negative under radical, so I pulled out an I. And then if you notice, I could divide all of these by 2, so I went ahead and did that. All right, so I'm going to scroll, so pause the video if you need to look more closely at the work. All right, and here are the last 4. Okay, nothing too crazy going on here. Had some big numbers. Just make sure you always take an I out if you have one, which is a negative underneath. All right, so I'm going to go ahead and move on to the last section of the notes, something really quick, but pause if you need to look at this work a little bit more, okay? All right, so the last thing we're going to talk about is the discriminant. The discriminant, if you notice, b squared minus 4ac, we've seen that before. That is the radicand. It's the value underneath the radical. And what it does is it helps us predict how many real solutions we are going to get. Okay, so if the discriminant ends up being positive, that tells us that we have two real solutions. That means the graph is crossing the x-axis 2 times, two different real solutions, two distinct real solutions. Okay, they might be pretty whole numbers, they might be decimals, but they're real numbers. If the value of my discriminant ends up being 0, so if I were doing the quad formula and I got the square root of 0, that tells me I have one real solution. Okay, that means there's only one intercept on the graph, and it's called a double root. So what that means is when you solved it, you got two of the same exact answers. Because remember, anytime we solve a quadratic, we should get two answers, just sometimes they're the same values. So that would be a double root. The vertex is the x-intercept. All right, and what that looks like in terms of a quadratic is if I have this. Okay, if I'm going to solve this and I factor, I end up getting x minus 2 times x minus 2. So notice I have two of the same factors. It's a perfect square trinomial. And then when I solve, I get 2 and 2. So I still have two answers. They're just not distinct. They're not different. Okay, so that would be, when I graph that, a double root. If I did the b squared minus 4 times a times c, I would end up with 16 minus 16, or 0. So that the fact that that's a 0 tells me that I have a double root. Okay, they're two of the same. Yeah. And the last concept is if the discriminant's a negative, that means I'm going to have 0 real solutions. Instead, I have two complex numbers with imaginary parts. Okay, so 0 reals, if I solve it, I still get answers, but they have i's in them. So you just got to look at something and ask, if it's asking you about the nature of the roots, just look at how it's being worded to determine if they're, what type of roots you have. But just remember, when there's 0 reals, that means the graph doesn't actually cross the x-axis at all. It's just floating above or below. All right, so practice with this. All I'm really doing is saying, hey, find your discriminant and interpret it. Okay, so our directions are to identify the discriminant for the following and determine the nature of the roots. So just like with your quadratic formula, everything does need to be on one side. So we'll move everything to the left. And when I add 9, I get a 0 there. Okay, you didn't need to write plus 0, but I just want to show you. So I'm going to go ahead and do b squared, so 3 squared minus 4 times a times c. And when I simplify this, okay, there's no square root or anything, I'm just simplifying this, I end up getting 9. So the 9 is my discriminant. It's not a solution, it's my discriminant. And all I'm going to use is interpret how many solutions or the types of roots I have. So because that's a positive number, I have two real solutions. That's all it does, tells me the type of solutions I have. Number 2, if I move my 9 over. All right, I do b squared minus 4 times a times c. Okay, when I do that, I get 169. So once again, since it's positive, it tells me I have two real solutions. Now something else I can kind of tell you is, because the discriminant is also a perfect square in both of these cases, I know my solutions are going to be whole numbers, just because it's a perfect square. So if I take the square root, just something to think about, not as super important. All right, go ahead, pause, try these couple on your own. Just find the discriminant and from there interpret the type of solution. 2 reals, 1 real, or 0 reals, but 2 imaginaries. All right, so taking a look at number 3, I ended up with 0 as my discriminant, so it tells me I have 1 real root. Number 6, I ended up with a negative, so it tells me that I have 0 reals but 2 imaginary roots. So my quadratic would not be crossing x, and my answer would have i's in it if I were asked to solve it. 5 was a positive, so 2 reals. 6 was also 0, so 1 real or a double root. All right, and that is the end of our lesson. So please come on down with any questions.